And let's learn how to calculate the confidence interval of a mean. Hopefully I will learn how to type. So this is when let's say that we take a sample of all of the students in our class. We have about 20 students in our class. We find their average heights, and that comes out to 5 foot 8 inches tall. And then let's say that we want to know the average height of all geography students. So we have about 80 students. We're not going to measure all 80. We've only measured the 20 in our class. But we're pretty confident that our sample mean is going to be close to our population mean. But in statistics, we can't just say we're pretty confident. We've got to come up with a number that represents how confident we are that our sample mean is the same thing as our population mean. So to do that, let's look at the trees data set that comes in R. So in the trees data set, we have 3 variables: the girth of the tree, or the diameter of the trunk, the height of the tree, and the volume of lumber in the tree, and we have 31 observations. So let's say lowercase n for sample size. That's let's attach these data so that I don't have to keep typing that over and over again. Lowercase n, population size, or sample size, is equal to the length of height. So n is equal to 31. And let's say that our population mean, we know that there are 100 trees out in the forest. And our m is our mean of height. So on average, these trees were 76 feet tall. But I want to know how, plus or minus that mean, how confident are we that our population mean is within there. So we're going to establish a confidence interval, or sorry, a confidence level. 0.9. So I want to be 90% confident that the population mean falls within plus or minus something of the sample mean. I need to calculate what that something is. So here's the equation. This is the population mean is equal to the sample mean plus or minus, and here's where that plus or minus number comes in right here, the standard deviation of the sample divided by the square root of the sample size. But we have to multiply that by a z-score. The z-score comes from the t-distribution. Z is the number of standard deviations away from the center, away from the mean, that contains 90% of the area under the curve. 90 because I just picked a confidence level of 90. We could have said 95, we could have said 80, we could have said anything. But since I picked 90, I want 90% of the area under this curve to be the white area, and 5% to be in this tail, and 5% to be in this tail. So here's the only confusing thing about this. If I want a 90% confidence level, then I need to find the 95th probability, right? Because here's 90% and here's 5%. So this line right here represents the 95th probability, right? So back in R, my z-score is going to be equal to the t-distribution function. And I could in here type 0.95. I'm always a little concerned that I'll forget to do that. So one thing that I've noticed that some scripters do is they will say 1 plus my confidence level divided by 2. So 1 plus 90 is 1.9 divided by 2 is 0.95. So that gets me to the 95th probability in order to establish a 90% confidence interval. Then I have to supply degrees of freedom here, which is always n equals 1, or n minus 1. So my z-score here is 1.69. So for a 90th percentile, I have to be about 1.7 standard deviations away from the mean. Now this drawing right here, I must have been the 95th percentile because it looks like it's about 2.4. But this is the number, 1.69, that separates right here 90% of the area in here and 5% in each tail. And that's the z-score. So the standard error, the other part of that equation, is just the standard deviation of the sample divided by the square root of the sample size. So the standard deviation of height divided by the square root of n. And then to get my confidence interval, I just multiply z times SE, which in this case is now 1.94. So if I take my mean minus the confidence interval, and my mean plus the confidence interval, what I'm saying is that since I have a 90% confidence interval, and my mean up here is 76, I'm going to say my sample size was 76, but I am 90% confident that my population mean is greater than 74 and less than 78. And that's how you calculate a confidence interval of a mean.